Hello, everybody, and another day of a wonderful lesson with Mr. Wheezy. So, kickoff. Again, I'm going to let you go back, look at the notes. If you want to answer that one, we're just going to skip over it for now. Just trying to save some time on these videos so that you guys don't have so much to watch. And, yeah. But, kind of got a taste of it last lesson. Now we're going to do proofs with this coordinate geometry. And I know you guys are all going, no, but it's going to be okay. We're going to get this. So, starting off, we have the mid-segment of a trapezoid is a segment that joins the midpoints of the non-parallel sides, just like in a triangle. We had that. Mid-segment of the triangle cut in at the midpoints of that triangle. Same things apply here. That mid-segment is going to be parallel to the base. However, what's different from the triangle is since we have two bases, we're actually parallel to the top and parallel to the bottom. So all three of those lines are going to be parallel. The other part of this is that the length of the mid-segment is going to be half the length of what the sum of the bases is. Before with the triangle, it was just straight up half of that base. Here you have to add the top base and the bottom base together, and then you cut it in half. So a little different, but yet a little bit the same. Now, proof of that, we would start by doing this here. We would place the vertex of the trapezoid on the origin of the coordinate plane with the bottom base on the x-axis. So that's what we've done here. We have this base going out like so. We've gone through, we've given our points all a value here. So P is 2a, comma 0. A then is 2d, comma 2c, and R is 2b, comma 2c. So we've given those, again, they're different lengths. However, because these are all parallel, the 2c and 2c stay the same because their height should be the same, but each one will have a different x, unfortunately. Now, from there, we know we're going to have midpoints. So again, that's where we use those multiples of 2's to name the coordinates. That'll make it so much nicer. So the first thing you're going to do is find those midpoints. And then you would go and show that they're parallel by finding all their slopes. And then lastly, you would compare the lengths by finding the distance formula. Now, I am going to do that here and show you, even though the notes do not have you do that. I'm going to try to slide this up a little bit further. There we go. So, start with midpoints. Midpoint formula is x1 plus x2 over 2. And then y1 plus y2 over 2. So to find m would be between t and r. Again, putting this on the origin, this point is 0, comma 0. So when we find m, our x would be 2b plus 0 over 2. Our y's would be 2c over 0. Or plus 0, sorry, over 2. Zeros would cancel, so therefore the 2's can cancel out. And we're going to get b, comma c as our point. The next part of this would be n. N is going to be between a and p. So here we're going to get a little more complicated, but again, it'll be manageable. We'll be just fine. We have 2a plus 2d over 2. And then our y's would be 2c plus 0 over 2. 2's will all cancel. And so our first part will be a plus d. Here, add 0 cancels out, and we just have a c. All right. So those are our midpoints. So we could write those in here. This would be a plus d, comma c. Here will be b, comma c. So midpoints. The next part of this is we're going to find slopes. So slope formula is your y2 minus y1 over x2 minus x1. Now again, you're thinking, we have all these letters. This is going to be a jumbled mess. It's really going to work out to be quite nicely, trust me. So let's start with RA. So slope of RA. We're going to do the y's first. So 2c minus 2c over, we're going to have 2d minus 2b. If I have 2c's and I take 2c's away, I'm going to be 0 over 2d minus 2b, which is just 0. Works out to be really nice. So now mn. So y's will be c minus c over a plus d minus b. C minus c is 0 again, which makes the whole thing be 0. Last one is we're going to do TP. And don't be throwing any TP. That's valuable right now. So y's would be 0 minus 0 over 2a minus 0. Well, 0 minus 0 again is 0. All three slopes are the same. So therefore, mn is parallel to TP, which is parallel to RA. And all that's going to be true. Okay. Turn my paper a little bit here. So, the last part of this is we need to show that their distances are going to be, if we add the two bases together and cut that in half, that's what mn is going to be. So, distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we start with RA. RA, if we do our x's, would be the square root of 2b minus 2d. I should do that the other way. 2d minus 2a. B squared plus 2c minus 2c squared. Well, that's just going to be 0, which is all going to cancel. And so these here can cancel as well. And so our distance of RA is going to be 2d minus 2b. Mn next. So, square root of a plus d minus b squared plus c minus c squared. Again, that's 0. So then our square root and our square can cancel. And we're going to be left with a plus d minus b. Lastly, TP. So 2a minus 0 squared plus 0 minus 0 squared. Well, that's just 0 and gone. Those can cancel, and anything minus 0 is 0. So we're going to be left with 2a. So if we add these two together, we would have, so TP plus RA would give us 2a plus 2d minus 2b. And we need to be half of that, so we're going to cut that in half, since that's what we're needing here, half of that put together. So the 2's would all cancel, and we'd be left with a plus d minus b, which fits that. So therefore, our distances are right where we need them. And there's our proof. So this is something extra that I put down just because I know some of you are going to have questions on how to do this. And just this explanation isn't going to be enough. It's also something I've done in the past that I've had on quizzes or a test. I don't remember which one it is. But this way, this will kind of give you kind of an explanation then, since we won't actually do that, since I don't know if we're going to do quizzes or tests yet. Or especially not tests, but possibly still quizzes as like a practice. So this way, you kind of are prepared of what's going to happen there. So, a rectangular flag is going to be constructed by connecting the midpoints of its sides. Use the coordinate geometry to prove that the figure that is created is a rhombus. So, we are going to prove this here. So, we know that MNPO is a rectangle that has midpoints of T, W, V, and U. Now, we'll see if this ends up making a rhombus with that inner shape, but for right now, all we know is the outsides are a rectangle. And so you see they placed it here again on the origin, where this is at 0, 0. P here is at 2a, comma 0. N is at 2a, comma 2b, because they're going to be the same distance across but a different height. And here we're going to be at 0, 2b. So, they've placed it on the plane, used multiples of 2 to name the coordinates. So that part's already done. The next part is we need to find what these midpoints are. So again, midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay. So if we start with t here. To be honest, usually when we do this in class, each group does one and makes it so much faster. But this is what we have to work with. So t, midpoint between 0, 2b and 0, 0. So x's would be 0 plus 0 over 2. Y's would be 2b plus 0 over 2. Which results in, well, 0 plus 0 is 0. 0 over 2 is still 0. 2b plus 0 would just be 2b, and the 2's would cancel, so 0b. Next up is w. W is up top here. So add the x's, which would be 2a plus 0 over 2. And then add the y's, which would be 2b and 2b. So 2b plus 2b over 2. Well, that end up would be 4b. And if we cut that in half, we'd end up with 2a comma 2b. Because adding 0 is itself. And then we can cut, actually we can cut the 2, so this is just an a. Wow. Sorry, getting ahead of myself. So, we have v next. V is over here, so if we add the x's, we would have 2a plus 2a over 2. If we add the y's, we'd have 2b plus 0 over 2. And 0 is anything is itself, the 2's cancel. Here, 2's are reduced to be 2a comma b. And lastly, u. U is between our 0, 0 and 2a. So if we have the x's, 2a plus 0 over 2. Our y's would be 0 plus 0 over 2. So anything adding 0 is itself. And the 2's cancel to equal to be a comma 0. So those are our 4 midpoints. Next thing is we're going to check distances. So we need to have all be the same distance in order for them to be a rhombus. We need all the sides to be the same. So distance formula, if you don't remember, d equals square root x2 minus x1 squared plus y2 minus y1 squared. TW, which I gotta say, best initials ever. Just saying. Best 2 letters right there. If only they had an M in the middle. Just saying. I know. I can't make jokes. Or the jokes aren't the same because you're not here in class and you can't laugh at my bad jokes. Even though you guys usually don't laugh anyway. But in my mind, I'm pretending that you guys are laughing while you're hearing this. Anywho. TW, if we start there. So distance between those two. So square root of our x's, which will be a minus 0 squared, plus we have 2b minus b squared. So inside here, anything minus 0 is itself. So we end up with a square root of a squared. 2b minus b is just b plus b squared. And that's as far as we can take it because they each have a square, but they're plussed in the middle, so we can't square root it. So to WV. So these here two. X's, we would have 2a minus an a squared plus b minus 2b squared. So 2a minus a would just be an a, which squared is a squared. Here, b minus 2b would be a negative b, but squaring it makes it a positive b squared. So far, so good. VU now would be the two over here on this side. So square root 2a minus a squared plus our b's, which would be b minus 0 squared. 2a minus a is a, b minus 0 is b. So again, square root a squared plus b squared. Again, so far so good. Let's make sure the last one's good. UT, which are these two. So we would have the square root of, let's go a minus 0 squared plus 0 minus b squared. Well, the zeros would go away. So we'd end up with, well, a squared. Negative b squared, though, would be a plus b squared. And we all fit. So that is it for this lesson. This is also it for this chapter. What I'm thinking of is I'll probably put together a chapter review type study guide type thing that I'll just have you do on your own. And it'll just be kind of a deal. You know, maybe if we ever come back to school here this semester, then you can use that as a study guide type of a thing to do the test. Maybe we'll just drop the test and we'll never do it even if we come back. I don't know. But for right now, we're not going to do the test, but we'll kind of do something to kind of tie this all together and make sure you're good to go with the whole thing. But as always, any questions, comments, concerns, please message me, pan me, email, Google Classroom. Any of those work, whatever's best for you. If there was something that you didn't quite get, again, go back through, rewatch it, or pause it if you need time to write something down that I got going too fast. You know, and then you can get everything written down you need to. But until next time, we'll talk to you guys later.